So, in this video, we are going to study about irrational numbers. So, before starting about the concept of irrational numbers, we should know the concept of terminating decimals and repeating decimal. So, firstly, we will start with the definition of terminating decimal. So, definition of terminating decimal is every fraction p by q can be expressed as a decimal if the decimal expression of p by q terminates, that is, it comes to an end, then the decimal so obtained is called a terminating decimal. What is the meaning of this definition? Suppose we are given any fraction p by q which is equal to 1 by 4. So we can represent this 1 by 4 as decimal. How we will represent 1 by 4 as decimal? We will divide 1 by 4. By normal division we will see that 1 by 4 is equal to 0.25. We see that the remainder is 0 and there are no more digits after 5. So this type of fraction is known as terminating decimal. Another example is 2 3 by 5. First of all, we will convert this mixed fraction into improper fraction. So 5 2s are 10, 10 plus 3, 13, 13 by 5. So if we normally divide 13 by 5, we will get 2.6. There will be no decimal place after 6. So this decimal will be terminating decimal. So we can say that 1 by 4, 2, 3 by 5 can be expressed in the form of a terminating decimal. So in terminating decimals, two types of question are asked in the exam. The first type of question will be suppose the first type of question is express 1 by 4 in the form of decimal. So what you have to do? Simply divide 1 by 4 and the answer will be 0.25. Now the second type of question which is asked in the exam is this one. Without actual division, find which of the following rational numbers are terminating decimal. You will be given some fraction. So without dividing, now you don't have to divide. Without dividing these fraction, you have to find that whether these rational number are terminating decimals or not. So now we will use this concept. A fraction p by q is a terminating decimal only when the prime factors of q are 2 and 5 only. So we will be given a rational number. So we will take first rational number 5 by 32. So what we have to do? First of all, we have to write the denominator. So denominator of 5 by 32 is 32. Now we will write all the factors of 32. So factors of 32 are 2 into 2 into 2 into 2 into 2. That is equal to 2 to the power 5. So the factors of the denominator, factors of q is 2 only. So this decimal will be terminating decimal. We should note that the factors of the denominator should be 2 and 5 only. Suppose there is any other factor. For example, in this question, 8 by 35. 35 is the denominator. And what are the factors of 35? 7 into 5. So we have 7. The prime factor of 35 is 7 other than 2. So this fraction, this rational number will be non-terminating decimal. Now we will take second example, 13 by 80. Denominator is 80. 80 can be written as 2 to the power 4 into 5. Factors are 2 and 5 only. So 13 by 80 is terminating decimal. We can check by actual division. If we divide 13 by 80, we will get terminating decimal. Now the third example, 5 by 24. So factors of 24 are 2 to the power 3 and 3. So 24 has a prime factor 3 other than 2 and 5. So 5 by 24 is non-terminating decimal. Now we will study about repeating decimals. So what is the definition of repeating decimal? A decimal in which a digit or a set of digits repeat periodically is called a repeating or a recurring decimal. What does it mean? If we are given any fraction, suppose we are given 2 by 3 and we have to write the decimal expression of 2 by 3. So what we will do? We will divide 2 by 3. On normal division, we will see that when 2 is divided by 3, we get 0.6666 and so on. So we observe that the decimal expression does not comes to an end. In this case, 6 is getting repeated. So 2 by 3 can be written as 0.6 bar. So this is known as repeating or recurring decimal. Similarly, if we are given 2 by 11. So if we divide 2 by 11, we observe that 2 by 11 is equal to 0.18, 18, 18 and so on. Each time we get the string of remainder. And what are the remainder? The remainders will be 2, 9, 2, 9 and so on, which is repeated. So 2 by 11 will be equal to 0.18 bar. So this is also a repeating decimal. Now we have some important notes, important points to remember. The first one is every rational number is expressible either as terminating decimal or as a repeating decimal. We can express all rational number. Suppose we can write 2 by 3 as repeating decimal, or in the previous example we wrote 1 by 4 as terminating decimal. So every rational number is expressible either as terminating decimal or as a repeating decimal. Every terminating decimal is a rational number. Every terminating decimal is a rational number. And the third point is every repeating decimal is a rational number. All repeating decimals are rational number. Now we will discuss our main definition. Definition of irrational numbers. A number which can neither be expressed as a terminating decimal nor as a repeating decimal is called an irrational number. So, non-terminating, non-repeating decimals are irrational number. Example 0.01, 001, 0001, 00001 and so on. This is non-terminating. It means the digits of decimal does not comes to an end. And non-repeating, we observe that the digits are not getting repeated. So this is an irrational number. Similarly, our second example is 0.12, 112, 1112, 11112, 11112 and so on. Root 2, root 3, root 5 are all irrational numbers. And the another example is the value of pi. Value of pi is equal to 3.14159265358997 and so on. So pi is also a irrational number. So now I will give some questions for practice. So the first question is express 3 by 40 as decimal. And the second question is, without actual division, find which of the following rationals are terminating decimal. First one is 5 upon 120. Second one is 16 upon 125. Third one is 9 upon 16. And fourth one is 2, 5 by 12. Please write your answers in the comment section. So this is all for today. In our next video, we will discuss about real numbers.